We're now on to question 3, and just by looking at this, I can tell this is a level up from the previous 2 that we've done, because if you look carefully at this question, both your left-hand side and your right-hand side can be simplified. So sometimes we tend to have that level 3 or level 4 question where both sides require you to simplify. So we'll start off with the left-hand side as usual. So here's what we have: 1 over cos x plus 1 times cos x minus 1. Let's simplify that denominator. So seeing that our brackets are different, you would obviously have to apply the FOIL method here and then gather like terms. So we're going to have cos x times cos x, which is cos squared x. Then cos x times negative 1 is negative cos x. Positive 1 times cos x is positive cos x, and positive 1 times negative 1 is negative 1. Now what you notice is that at the bottom you've got negative cos x plus cos x. They can cancel out with each other. So what we are left with in the numerator is 1, and in the denominator cos squared x minus 1. Now, if this denominator, cos squared x minus 1, looks familiar, it's because it actually comes from your identity. So remember your identity, sin squared x plus cos squared x equals 1. This identity can be manipulated and very often is attested in the manipulated way. So manipulating this, we have to think, how can we get cos squared x minus 1? Now that can be achieved easily if we keep the cos squared x on the left hand side and we take this 1 over to the left, so it becomes negative 1. But at the same time we take the sin squared x over to the right. However, when it goes over to the right, it becomes negative sin squared x. So your denominator, where you've got cos squared x minus 1, can now be replaced with negative sin squared x. So doing so, here's what you get. Now remember that it is a fraction, so you don't have to keep that negative at the bottom. The negative can be moved to the front of the fraction where it's in line with your division sign. That negative can also be put in your numerator. So if you want to keep it like this, it's fine though, right? As long as we know that this fraction is now negative. Now, like I said at the start, this question is one where you will have to simplify the left-hand side as well as the right-hand side. So notice how we've simplified the left as much as we could, but we did not get to the right-hand side. There's no way that you're just going to get tan squared x out of the sign that we have. Instead, we're now going to leave this last step as is. We're going to start working with the right-hand side. And we're going to simplify the right-hand side so that it now looks like this last step. So when we simplify the right-hand side, we also need to get this fraction, this negative fraction of 1 over sin squared x. So let's start off by writing down what the right-hand side is equal to. So here's what we have. And in the denominator, let us expand tan squared x. So we know that's going to be sin squared x over cos squared x. That is being multiplied by cos squared x. What happens here is the cos squared x from the denominator cancels out with that cos squared x next to it. And immediately we notice that we're left with negative 1 over sin squared x, which happens to be exactly the same as what the left-hand side had simplified to. So both the left and the right-hand side have simplified to the exact same fraction, which means that we can just conclude and say, therefore, left-hand side is equal to right-hand side. And that is it. So we are done here. So if ever you have a question where you're simplifying and you notice that you've simplified the left as much as you could, but it doesn't look like the right-hand side, try simplifying the right as well. As long as you get them to equal to the same thing, essentially, they are equal to each other. Please remember to like, subscribe, and turn on your notifications for more content.